Hey guys, welcome back to chapter 14. In this video, we are going to take what we learned about pH and apply it to like actual acid-base problems. So instead of just giving you what's hydronium, what's hydroxide concentration, I'm going to give you like an actual molecule and ask you to solve for pH. We're going to start this section with strong acids. So remember, for strong acids, there was the big five. So these five you're just going to have to know, be able to recognize quickly. So the big five were hydrochloric acid, hydrobromic acid, hydroiodic acid, and then for the polyatomics we had nitric and sulfuric. So finding the pH of a strong acid. The question that we're going to solve eventually is, what is the pH of 0.1 molar HCl? So we have to think about, what does it mean to be a strong acid? What it means to be a strong acid is that there is complete dissociation of those ions. So the hydrogen ion, the chlorine ion, completely dissociate or break apart into solution. Okay. So if I have a solution that is 0.1 molar HCl, once I drop that into water, I will then have a solution that has 0.1 molar chlorine ions and 0.1 molar hydronium ions. Because there's a complete dissociation for every molecule that I put in, I'm going to have one molecule of hydronium on the other side. I put 3 molecules of hydrochloric acid in, I'm going to have 3 molecules of hydronium once it dissociates. So the big take home here is that for a strong acid, and this is only true for strong acids, the concentration of the acid is equal to the concentration of the hydronium ion. So if I give you the acid's concentration, if it's strong, I've essentially given you the hydronium ion's concentration. So in this case, we have 0.1 molar HCl. I also can make the statement that I have 0.1 molar hydronium ion concentration. So I've essentially given that to you. So now it becomes a really easy plug and chug problem. So if I know the hydronium ion concentration, I simply plug it into the negative log of hydronium, so 0.1, and I get that the pH equals, so negative log of 0.1, the pH is 1. And I always want to make sure we ask ourselves, does this make sense? We know hydrochloric acid is a strong acid. So having a pH of 1, does that make sense to us? Yeah, it does. It should be a really low pH. Now we're going to talk about the pH of a strong base. So a lot of the same assumptions can be made. So again, with a strong base, there's going to be complete dissociation. So for every molecule of sodium hydroxide I put in, it's going to completely dissociate or break apart into calcium. But here's where we have to be careful. Remember, bases should already put a red flag up. It's not going to break apart into one hydroxide. For our group 2 metals, it's going to break apart into 2 hydroxides. So very similar statement that we made for strong acids is that the hydroxide concentration for a strong base will be equal to the concentration of that base, right? That was the same statement. But we also have this kind of added layer where we have to consider how many hydroxides are taking place, okay? If it was just simply something like NaOH, then we would have that like 1-to-1 ratio. So the hydroxide concentration would equal this concentration, right? Because it's just one OH. But with our group 2 metals, we have that kind of extra thought with the 2 hydroxides. So that's where this statement comes in. But now that we know that, we can solve for the POH. So POH is going to be the negative log. I'm going to take the concentration that it gave me, 0.2, and I'm going to multiply that by 2 because of this subscript right here. So I'm going to take the negative log of 0.4. So the POH equals negative log of 0.4. The POH equals 0.39. And then quite often it is not asking about POH. Quite often it's going to ask about pH. So we just need to know that the pH equals 14 minus the POH. So pH equals roughly 13.6. And again, we ask ourselves, does that make sense? Yes, it's a strong base. It's got an extremely high pH. That makes sense to me. So that's it for the introduction of strong acids and strong bases and solving for pH. In summary, the concentration of a strong base is also the concentration of hydronium. And the concentration of hydroxide is also the concentration of the strong base, taking into consideration how many hydroxides are present. I hope you guys found this helpful.